Hi, Lo. It's Muffly. I hope you're doing great. Hope the baby's doing good too. Um, I just made up the slide because I want to um, just kind of talk through my name matching strategy. Names are difficult. People use uh, the, their name as Zach when their real name is Zachary, or Lo when their real name is Laura. So, or Ty when their real name is Tyler. So, people get married, um, change their last names, or alter it. So, anyway, um, it's a constant struggle, and I wanted to show kind of how um, we addressed it. So, one thing was that I downloaded all the OBGYN and healthcare student taxonomy codes, and that is a huge file that can't actually fit into the RAM of my um, MacBook computer. And so I read it in with some database software called DuckDB, and I'm using this R software to run that, filtered it out, got it to a normal size so that we can use R. You kindly provided the source of names needing NPI numbers with the data scraped from the different websites. And so I did an exact match of first and last names. I did a match on the first and last names plus the state name. I tried some fuzzy matching, which is this zoomer join package where there's like a one-to-many relationship. It wasn't that helpful, honestly, but I added it for completeness sake. Remove duplicate NPIs, then kept looking and said we've got to do better. There's a package in R called NPI, which is a fantastic package. I created a wrapper around it, basically an R file that downloads the data in batches because it's usually meant to be just a single search and done. And so instead of the batches, instead of the singles, it used batches, and it had this first name alias. So Ty becomes Tyler, Zach becomes Zachary. So that was very helpful. I did then upload the unmatched names to Mechanical Turk, the Amazon service, and spent a little bit of money getting matches that way. The nice thing about that is that all the matches are sent out. Excuse me. At one time, and everybody can work in parallel, right? So, and that gave this final list of names that are all specialty taxonomy specific, that are pretty close. During this time, I used some version control, just saving the data as we go along in this. Some of these files are pretty large, so we're using the get large file system. So how does this look in practice? This is my exploratory.io, and we've got a directory here. This is just the list of providers that you had uploaded to the Google Sheets, and then I did a little bit of cleaning, and then this is the first join. This is the NPPES file from, you can see 2024-0705. So from July 5th, 2024, this is the most recent data that we have. And we did an exact name. That's what the double equal signs mean here. And so we were able to start to get matches. So and we matched it in a couple different ways. I split out residents and attendings because that was one way that we could minimize, Joseph Smith or John Smith being overlapped so many bazillion times. And then brought in data where there was a match based on first and last name. There was a match based on first, last name, and state. There was a match based on the last name, and it just kept going on and on and on, and brought in the MTurk data here, and then finally coalesced all these files, their MPI search, into one file. So basically we're automating the hand search here, that you would put in somebody's information and get their NPI number back. So this is for me, obviously, but we have, a huge number of people that we need to do that with. And so this is that NPI R package that's been incredibly helpful. So so to go back to this, this has allowed me to get all but about 10% of the names matched to an NPI number, and I'm confident that that in those 90% of searches. So it's going to require some, a little bit of heavy lifting to get the remaining 1,200,000 or so, but I think we can do it. All right, talk more. Thanks, bye.